Hello, I'm Peter Ballant from Technikon. Welcome to this special video interview series where we talk with experts in the field. Today we're looking at the Safe4RAIL-2 project. This is a multi-million euro project which aims to improve the passenger train here in Europe by streamlining various different train functions. Many of these improvements can be made by bringing wireless communication on board. Here to tell us more is Liesbet Van der Perre. Liesbet is a professor in the electrical engineering department at KU Leuven in Belgium. Her main research interests are in energy-efficient wireless communication for IoT and beyond 5G systems. She has authored and co-authored many scientific publications on the topic, and today she joins us to share her views on how 5G could improve the safety and reliability of passenger trains in Europe. Welcome.
Thank you.
And so what are your thoughts about bringing wireless components onto trains to replace what has been wired for so many years?
Well, first of all, I'm very happy it happens because for many decades already and still today, one of the most recurring fears about wireless is that it would not be reliable enough. People all see the advantages of wireless. It's much more flexible. You don't have to connect the wires and so on. And even you could say, well, it's much more modular. But the main question people have is, can it really be reliable? Can you trust on wireless communication for functions like, for example, in a train where you want safety to be really a primary thing? And there we have seen for so many years that if a real disaster happens somewhere, often it's wires that are out. Wires are broken, wired networks are out. And then the way to still get in contact with people is through mobile phones, through wireless communication. In the past, even before mobile phones, there were emergency networks that only worked in a wireless fashion. So I'm happy to see that more and more people trust wireless to be a solution that physically can be much more reliable actually than wired communication. So I'm very happy this happens. And we should for sure make sure that what we achieve in terms of communication reliability is high as well. And I think that's where the newer wireless interfaces that are there and that are in development play an important role and bring important features that can help.
Okay. And let's look at 5G specifically. Tell us about the general capabilities of 5G in comparison to LTE or 4G.
Well, 5G has been designed, of intended to be designed to cope with different new access where we want to see improvement on wireless networks. The first one is just as usual, I would have said, when going from one generation to the next one, we want to have higher capacity. And that's one of the things that 5G has been working on as well, or targeting, is what we call the enhanced mobile broadband, is that the mobile broadband connectivity would get better, mostly deliver higher throughputs for many more users. So that, for example, in scenarios where you have a lot of people coming together and current networks don't suffice, this could be a support. But also that mobility in terms of how fast can a user move and still receive a good broadband connection, that this should be able to go up. And of course, that is interesting on board of terrains that, well, going up to several hundred kilometers per hour, we should still be able to keep the broadband connection. So that's the first axis, often the one that is first also realized in practice, because it's, I think, where most of the traditional business for operators and infrastructure builders and so on is. But 5G also had the intention to support two other axes where we want to make progress. And one of them is ultra reliable, low latency communication. And this specifically is important in what we call critical applications and potentially dependable applications. So, applications that depend on wireless connectivity to deliver a service. And of course, I think many of the train services that is being looked at could benefit from this part of the 5G solutions. It's not going to be a one-fit-all solutions. There are a number of technologies that fit in 5G, and being something which is ultra reliable in the sense that no packet get lost, but also very low latency, such that you don't have to wait for the correct packet to come in, but that you can have very short reaction times, I think is a very important feature for a lot of the new applications we see that we hope 5G will support. And this can be on board of trains, the things anticipated, but can also be, for example, if you want to think about the future of the self-driving car, where personally I don't think it will happen with the first generations of 5G, but we move in this direction of autonomous vehicles that are completely supported by wireless communication to achieve their goals. Well, there you have to be very low latency. You don't want a response to be long. If an action needs to happen, it happens. It should happen directly. And I think for achieving that, there's been a number of technological steps to be taken, and some first of them are already taken in 5G. So I don't think the first generations of 5G, because there will be several generations like we also had with LTE, will have a considerable improvement. Yes, but not sufficient for really autonomous systems. But for sure, it's a new parameter that people have been thinking of. I think a lot of mobile networks in the past were designed to have high throughputs, to have better videos for everyone and so on, to support internet traffic mostly in terms of we download things and we watch them. But more and more, we want to go to things that are interactive and that are getting into new applications like dependable applications. So I think that part of 5G, which is on ultra reliable, low latency communication, for sure is also very relevant for what we want to do on board of trains. The third axis is supporting massive IoT, a very large number of Internet of Things applications that should be very low power. Well, there, I'm not sure this is so relevant for what you want to do on board of a train. And also, I'm afraid that first generations of 5G have not been focusing on that because maybe the other ones, from a business point of view, were more stringent and more required and more urgent to support. So I think the third axis of 5G will be the latest one, may also bring great improvements or great benefits for other applications like environmental monitoring and deploying strategies for sustainable societies for sure. But on board of trains, I think the two first axes, so the enhanced mobile broadband and the ultra reliable low latency communication, can bring in the future, or maybe on the short or the longer term future, great new value, I would say.
So there's undoubtedly great potential here. And with great potential comes challenges also. What kind of challenges do you see that might have to be addressed to successfully roll out 5G or any type of wireless in a train railway kind of situation?
Well, I think a first one is not purely a technical one. It's a political and also financial one. Is that 5G? It's a full new generation, and new license to the spectrum has to be released. And I think what will be important, and we already did a bit of that in 4G, is to select priorities in that network to make sure that if you need to have a very high reliability, that can be part of the network, and that is part of the things that will be implemented. There will be things like software-defined networking and slicing, where you could say you have to make sure that you have some priority lanes, let's say, like would have them in other traffic situations, but then on wireless networks, priority lanes that can be preserved for having priority communication. Because if there is a lot of traffic around, you want to avoid that the network at a certain moment could be crowded and collapse while you are having some services in there. So I think getting a network up and running and deploying 5G all over Europe in many countries is still a challenge. And we want to have train systems that can work not only in one country, but all over, I would say. And then also in these networks, make sure that there is priority for certain services that you want to give priority. That's a number of challenges I see. I think another challenge I see is that specifically for what I was saying, the enhanced mobile broadband, one of the things that is considered to use newer, higher frequencies, well, they're not new, but to use them for this kind of applications, to use millimeter wave frequencies. And they have a clear promise because there's a lot of bandwidth available there. And bandwidth available means there can be a lot of capacity. But the millimeter waves, I think, are very vulnerable for the fact that when you don't have a line of sight, a direct view, let's say, between transmit and receive, then it's very difficult to set up a reliable connection. So in order to have millimeter waves supporting this kind of application, you will need to be able to make sure you have line of sight connections to base station one after the other, have handovers that are proactive and so on. And so I think it's like a cable replacement without a cable, but the line should still be there. And millimeter waves, while there has been a lot of talk about it, it has been research for many decades now. And the main problem is still that you need this line of sight mostly. If you have a shadowing effect, if there's something between your transmitter and your receiver, yeah, the millimeter waves will have a problem. I think also high mobility for millimeter wave is still to be shown whether that's going to work well. So, for example, suppose you can, if a train is in a station and you want to have fast download of videos or whatever, then I think millimeter waves are perfect. And then if you would say, I know where the tracks are going, I can put infrastructure near to the tracks to really have very high speeds to a train with millimeter wave, that could also probably be an option, but that will be a huge investment in order to realize that, I think. So the millimeter waves, while promising for high throughput, and you could say in a train system, a railway system, practically you could see how you could make sure there is this line of sight. So it's quite well possible, I think, to install it, but the installation will be huge and the cost will also be huge. So there, I think there's still a challenge to be seen. Is millimeter wave for this kind of applications a good option, or should we refer to things that we call the golden frequencies below 6 gigahertz that are, I think, in coverage and supporting not necessarily a line of sight, or the better or the easier, at least, the easier to work with, and the more reliable, robust from that point of view, from the propagation aspects.
Okay. Well, thank you for sharing your knowledge with us today. Moving to wireless communication and especially 5G in the railway sector will certainly have a profound effect on trains as we know them. And the Safe4RAIL-2 project has done quite a bit to push this forward. So thanks for your insights. We appreciate it.
My pleasure.